Hello, everyone. I hope this finds you well. Hope everyone's staying happy and healthy. This is going to be the way that we handle lessons from here on out, and I hope it works okay for everyone. Essentially, instead of posting the PowerPoints weekly, I'm just going to be posting these videos, which will go through the PowerPoints, and you'll be able to pause them, go back, look through them as you will. But my expectation is that for every PowerPoint that we do, you should be doing that homework and then sending me either a picture of it or sending me your answers from them one way or another, so I know you're keeping up with the homework and you're staying together with the lessons. If something doesn't make sense or you don't understand something, feel free to send me a text, an email, something along those lines. Just get in contact. I'm more than happy to video chat, FaceTime, something along those lines to get everybody on the same page to make sure nobody's falling behind, because I know this transition can be difficult. So essentially, I'm going to break this long PowerPoint up into a small group of sections and post them each on the Canvas so that you can look through them as you please. You can go back and find what you need. So let's get started with Unit 3, Algebra Part 2. Okay. So we're going to start with simplifying expressions to solve equations. So we've seen before that expressions are mathematical phrases that don't have an equal sign in them. And we know that we have something called like terms. I think we've talked about this. We might have even done the first section of this when we were together, but it's been 2 weeks, so I figured we'd run through it again. Like terms are terms that have the exact same variable factors. For example, 3x and 7x are like terms, because if you look at their variables, an x and an x are exactly the same. That means you can add them. It's like adding apples and apples. If I have 3 apples and my friend has 4 apples, how many apples do we have together? We'd have 7 apples, right? So it enables us to add or subtract like terms. Like I said, 3 apples plus 7 apples, it's really like 3 plus 7, that'd give you 10 apples, right? Similarly, if we had y squared minus y squared, if we look at these two terms, they have the exact same variable, and the variable has the exact same exponent, so that means you can add or subtract them, such as 7 minus 1 equals 6y squared. We call this combining like terms. So let's take a look at this big problem. This looks daunting at first because there's a lot of things going on, but when you take it step by step, it shouldn't be that difficult. Remember, when we have a problem like this, we want to go through PEMDAS. So the first thing I want to look at is this parentheses. Is there anything inside this parentheses that I can get done first? Well, I have a 2a plus a 4b minus a 6c. A, B, and C are not like terms, so I cannot combine them. So my eyes move up. I don't see any exponents, so I move on to multiplication or division. And I do have this little negative sign right here that is being multiplied into this algebraic expression. So I can distribute this negative symbol. Negative times 2a becomes negative 2a, a negative positive 4b becomes a negative 4b, and a negative c becomes a positive 6c. Now that I've done the distribution, I don't need the parentheses anymore, so now I can combine some like terms. I want to group the things that match. So for example, I have a 3a minus a 2a. 3 minus 2 will be 1. Then I have this 4b, but I can't combine it with this 6c. But using the commutative property, I know I can add it to this 2b. So I could have negative 4b plus 2b, which will give us a negative 2b, and then a 6c minus 3c will give us a 3c. Now, if at any point you missed something that I said, you can always take a pause, or you can go back and look at it again. This is intended for you to be able to go at your own pace. So if you didn't understand something I said in here, you could take a look at it yourself and pause it as you need. So let's simplify this one. We have x's and we have x squareds. Those are almost the same, but they're not quite. This would be like adding like Red Delicious apples and Granny Smiths. They're sort of the same thing, but they're not quite, right? So I can't add a 3x plus a 14x squared because x squared and x are not exactly the same. So I want you to take a minute and think, well, what can I add together? I can add this 3x and this 11x. I can do 3 plus 11 which would give me 14. I can also do 14x squared plus an x squared. Remember, if you don't see a coefficient in front of this number, there's always a hidden 1, which is where this 1 right here comes from. So we would get 14 plus 1 gives us 15x squared. So this expression simplified is 15x squared plus 14x. All right, now we look at this example. I know this one was a little more daunting because we have two sets of parentheses, but if we use PEMDAS, it becomes simpler. If we have x minus 2 inside of both of our sets of parentheses, that's where we want to start, right? We look from the outside and we work in. So the outside has these brackets, then inside of them we have an x minus 2. But x minus 2 don't have the exact same variable, so we cannot do it. So we see this negative symbol on the outside, and we can distribute it in. And when we distribute this negative symbol in, we get negative x plus 2, because this negative symbol switches the signs of our x and our negative 2. Now we have 7 minus x plus 2. That's closer, right? We still can't do 7 minus x, but we can do 7 plus 2. 7 plus 2 will give us 9. Then we have 9 minus x. Again, we can't do that, so we look back to our parentheses, or our brackets in this case. And I see that I have a 4 outside, which means I can distribute it in. So I get 4 times 9 will give you 36, and 4 times negative x, which will give you negative 4x. Now from here, we're almost finished. Because I still don't have anything to combine with this negative 4x, I just bring it along for the ride. That stays negative 4x. However, I do have this at 6 plus 36, which becomes 42. Now, the thing that confuses a lot of people is when I say combining like terms, that only applies to addition and subtraction. You can multiply and divide two things that do not have the same variable, just like we did here, 4 times negative x. That just gives you negative 4x. The reason for this is because this number sitting right next to this x is still multiplication. There's a hidden little multiplication symbol right in here. So I didn't actually do 4 times x, I just have them next to each other for simplicity. All right, so to determine whether a number is a solution, we're just going to plug it in. And if it comes out to be a true statement, we know that it is a solution. So this question says, is 9 a solution of 3y minus 1 equals 2y plus 7? Let's plug it in and see. So when I plug in 9 to both sides, I get 3 times 9 is 27, minus 1 is 26. Then on the right side, I get 2 times 9 plus 7, so 2 times 9 is 18, 18 plus 7 is 25. Are those two equal to each other? 26 equals 25? No, they're not. And because they're not equal, we say it is not a solution. So now we can use combining like terms to solve equations. And we're going to go back to the additive property of equality and the multiplicative property of equality that we did last time. So for this example, before we would only have one x in our problems. And we would just subtract or multiply or divide to get the x by itself. But right now we have two x's. So the first step for a problem like this is combining your like terms. I'm going to do 7x minus 4x first. So the first thing we're going to do is 7x minus 4x, which will give us 3x. And now we want to get rid of this 3. So we have 3 times x equals 15. How do I get rid of the 3? Well, I do the opposite of multiplication, which would be division. I would divide both sides by 3, which would give you that x equals 5. And if you wanted to check that, you would just plug it back into the original problem. You get 35 minus 20 equals 15, and 15 equals 15, which is a true statement. Sometimes we're going to have equations that have variables on both sides. That's okay. What we're going to do is we're going to group our variables first. We want all of our variables on the exact same side. So for a problem like this, I have a 3x minus 15 equals 4x plus 36. And the first thing I want to do is move all of my x's to the same side. So I have two options. This is a positive 3x and a positive 4x. So I could either subtract my 3x over, or I could subtract my 4x over. Now, for simplicity's sake, I like subtracting the 3x, because I know 4 minus 3 will give us a 1x, and that'll make the problem easier. So I would subtract this 3x from both sides. Once you subtract the 3x from both sides, you end up with x plus 36 equals negative 15. And then from there, this just looks like a problem from section 2, right? All we have to do is subtract this 36 over. Once I subtract the 36 over, you get that negative 51 equals x. Sometimes we'll need to use the distributive property to solve equations, such as this example where we have 3 times x, 6x plus 15 equals 45. We actually have two methods for solving this problem. The first thing we can do is distribute this 3 in and get an answer. Or if you notice that this 3 is being multiplied by this whole section, you could actually start by dividing everything by 3. Now, the PowerPoint wants us to go with the distributive property, and I don't have a board to write on, so we're just going to go with what the PowerPoint wants us to do. So the first step in this problem is distributing this 3 in. We'll do 3 times 6x plus 3 times 15. 3 times 6 is going to be 18, and 3 times 15 is going to be 45. After we've done that, the problem becomes a lot easier. We have 18x plus 45 equals 45. And then from there, we remember the first thing we want to get rid of, remember we do backwards PEMDAS, is addition and subtraction. So I'm going to subtract this 45 over. We're going to get 18x equals 0. And is that an issue? We know sometimes when zeros come up, we have a little bit of a problem. But let's see. If we divide both sides by 18, we get that x equals 0. Is that okay? Yeah. 0 is just a number in this case. X can absolutely equal 0. So we can use our strategies for solving certain equations. And the strategy that we're going to use every single time for solving equations is this 4-step thing. We're going to start by simplifying each side of the equation, then isolating the variable on one side, which just means getting it by itself, then get the variable by itself, and then check the result. So start by simplifying both sides, then move the variable to the same side, then get the variable all by itself, and check the answer. So for example, we have this big long problem, but if we take it one step at a time, it immediately becomes easier. So the first thing I'm going to look at is this left side of the equal sign right here. I'm going to say, is this simplified? Is this all cleaned up? Or is there stuff we can do? Can we combine like terms? Can we make this easier? And if we look at it, yeah, we can. We have a couple options, right? This 6x is all by itself. We can't do anything with it yet. But I do have this distribution on the left. So I can distribute this 3 in and then simplify from there. And on the right side, if you notice, we actually have another distribution. So we can do both of those. So the first step is distributing this 3 in. We get 3 times 4x will give you 12x, and then 3 times 80 is 240. And on the right, we have 2 times x, which is 2x, and 2 times 40, which is 80. Now from there, we have to look and see if we can combine any like terms, right? Because we did parentheses, there are no exponents, so now we're looking for multiplication or division. There is none. We actually did that in the distribution step, and now we're going to do addition and subtraction. I have this 12x over here, right? And I can't combine past this equal sign yet, so the first thing that I see that I can combine it with is, not this 240, but this 6x. They both have an x with it, so I can do 12x plus 6x to give me an 18x on the left side. Now this 2x is already by itself, which is why I didn't change anything for it. Now, both sides are completely cleaned up. I don't have any more like terms to combine on either side of the equal sign, so now I want to get all my x's together. So let's subtract this 2x over and see what happens. Now I have 16x minus 240 equals 80. Well, now we can solve this. We can add this 240 over, then we can divide by 16 and get that x equals 20. All right, so that's going to be it for this first PowerPoint. Let me know if this works out well for you. I don't want to continue to do PowerPoints that people are not understanding or it's not coming across right. So please give me any feedback. You can text me or call me or send me an email. All that information is still in your syllabus, which is still in the Canvas. So yeah, let me know if this doesn't work for anybody or if it's confusing or if you have any questions about it. Thank you.